Alright, 10-4 video notes, volumes of pyramids and cones. So let's go ahead and get after this. Hopefully the class isn't too loud in the back and we can you can understand what I'm saying. So view, full screen. Let's go up. Alright, so the deal is with pyramids or cones, you're basically going to use the same formulas that you did yesterday, except for you're going to have this 1/3 in front of the base area. So I'm going to go off the grid for a quick second, and I want to kind of illustrate what I'm talking about. So let's say that you have a cylinder right here, and we know from 10.3 that the volume of the cylinder is pi r squared h. That's how much stuff it can hold. Now, if we were to put a cone perfectly inside here with the exact same base and the exact same height, and we were to put this cone or this funnel inside of there, and I was going to ask you, what would the volume of that cone be? Alright, well, what you would find out, and there's a big long proof for it, and we're not going to go through the proof, but I'm going to have you kind of trust me on this one. The volume of a cone is always going to be 1/3 of the volume of the cylinder that has the same exact height and the same exact circle. Now, to me, it looks like it would be more, but it's actually exactly 1/3. And you can do this with sand. You could kind of have like a paint can and a funnel inside of it of the exact same size, and you could fill that funnel up with sand, and you would pour exactly 3 of those funnels to fill up the entire cylinder. So that 1/3 is extremely important when you're dealing with pointy objects like pyramids and cones. Alright, so let's kind of jump back into the notes here. So basically, to find the volume of a pyramid, you pretend that it's a cylinder, but you just apply the 1/3. Some of you will find it might be easier to do the base area times the height and just divide by 3. So basically, you can divide by 3, or you can multiply by 1/3. And I'll try to do it both ways so that you can kind of decide which way works better for you. Alright, so let's go down, let's do some examples. Find the volume of each solid, round to the nearest tenth. If the solid is a cone, write your answer in terms of pi and as a decimal. So they want the exact answer and the approximate answer. So basically what you're going to do, the volume of any pyramid is 1/3 base area times height, or like I said before, if you want to do base area times height divided by 3, it all works. So the base area is a rectangle. So the base area is 5 times 3, or 15. And the height is right inside here. This is the height. Remember last time we talked about this out here was a slant height. You don't need that for volume. We want the true height. We actually want this h here. So the true height is 7. And so I crank this out. 1/3 times 15 is 5 times 7, or 35 cubic inches. Okay, just like yesterday, our units are cubic. Or you could have did over here, you could have had 105 divided by 3 if you didn't want to mess with the 1/3. So either way will work. Moving to the second side, we now have a cone. And again, volume formulas are so much faster than surface area formulas. So the volume of a cone is 1/3 pi r squared h. So this is just kind of a plug and chug. You have 1/3 pi radius squared times the height. And I'm going to work this out a little bit. I'm going to leave pi alone, and I'm just going to do all the numbers. So you can do it in any order you want. I'm going to do like 1/3 of 12 is 4. And then 4 squared is 16. So 4 times 16 is going to come out to be 64 pi. And now I actually need to multiply it out to get the exact answer. So I'm going to punch this in real quick. 64 pi is 201.06. And my units are cubic feet, or feet cubed, however you want to write it. So this is approximate. This is exact. All right, let's get after number 3. Number 3 is a composite shape. Number 3, I have 2 shapes I have to deal with. So to do this one, I'm going to actually do the volume of the cube, and then I'm going to add to that on top the volume of the pyramid. Okay, so I have to use the cube or the box and the pyramid. It's not a cube, I misspoke. Cube would have all 3 dimensions the same. This one doesn't. So the volume of a box, remember, is just length times width times height. So you have 6 times 3 times 5 for a grand total of 90. So that's the bottom portion. Now I need to add to that the pyramid. So the pyramid, remember, is just 1/3 of the base area times the height. So 1/3 base area is this right here, which is 6 by 3, so that's 18 for the base area. Not base average according to civils. And then the height is 6. So when I crank all that out together, 1/3 of 18 is 6, and 6 times 6 is 36. So I have a grand total, both shapes put together, of 126 cubic centimeters. Cubes. Alright, let's wrap this up. So a little real life problem down here. Egyptian pyramids, massive structures. We're going to try to find the volume of this thing. So Giza in Egypt sited the 3 great pyramids. Each one has a square base, which makes it easier. The largest pyramid was built for Khufu. Khufu must be one of the pharaohs there. When first built, it had a base average of 754 and a height of 481. Over centuries, the stone is eroded and taken away for newer buildings. Pyramid today has base average of 745 and 471 feet tall. So it's lost 10 feet in height. Find the difference. So find the difference between the original and the current volumes. So I got to do 2 things here. So let's do the original volume, and then we're going to subtract the current volume. And that's going to be the answer to the question, because they want to know, find the difference. So 1/3 base area times height. So for the original pyramid, it was the base area was 754 times 754, because that was the square base, times the height of 481. And then I'm going to subtract from that. Its current dimensions are 1/3 745 times 745 times the height is now 471. So I need to crank these out. Now I could have made my life a little easier, and I could have wrote this as just 754 squared, but I wanted to kind of keep it true to the formula. So let's bust these numbers out and see what we get. I got 1/3, I'm going to do 1 divided by 3 in parentheses, times 754 squared times 481. Holy smokes. That's 9115265.33, and that is cubic feet. Takeaway. Now nowadays it's 1 divided by 3 times 745 squared times 471, and that's 87138.925. So we're looking at millions. These are millions of cubic feet. So just ballparking, looks like 91 million minus 87 million. It's going to be somewhere around 4 million. Let's bust this out. 9115265.33 minus that last answer. 4,013,140, and didn't say where to go to. That'll be the nearest foot. Cubic feet, or feet cubed. So that pyramid has lost 4 million cubic feet since it was built, back whenever it was built. I don't really have a year on that. Alright, so volume of a pyramid and cone, or pyramids and cones, not too much different. You just got to put the 1/3 in front. This should get us ready for our practice tomorrow. See you.